So welcome back. We are going to analyze the problem in exercise 3.2. So 3.2, we are having a process of converting the crude glycerol. Of course, this is a vegetable oil-based product. The glycerol is a bio-based product. It can be converted to propanediol, 1,2-propanediol here. We put a short name, P-diol, and in order to do so, the glycerol will be first dehydrated to acetal, ACl, before the ACl can be further hydrogenated to P-diol. And the reactions happen in series. So we have equation 1. Okay. So the equation 1 here is from glycerol to acetal and water, because it's a dehydration reaction. And then once you get the acetal will react with hydrogen to produce 1,2-propanediol. Right. And other information given in this question is the feed. The crude glycerol consists of 70% weight percent of glycerol and the balance of water. Okay. And crude glycerol with a feed flow rate of 1 kmol per hour, and it is mixed with 5 kmol per hour of hydrogen before entering a reactor. Temperature and pressure of the feed are 200 degrees C and 1 bar respectively, and the reactor is operated at the same condition as the feed. And the resulted glycerol conversion to ACl is 80%, okay, while the ACl conversion to P-diol is 90%. Okay. We are having two conversions here. One is for the first reaction, second is for the second reaction, for acetal to be hydrogenated to propanediol. You need to simulate the reaction using an RTL-RK method and determine the followings. So we have the heat of reaction and also the selectivity of the propanediol. Now, let's analyze exercise 3.2. So selectivity, just to revisit the equation for selectivity, it is actually the amount of product over the amount of reactant converted. Okay? That is representing the terms of selectivity. That means out of the reactant converted, we would not like to know how much is being converted to our desired product. Okay? And the components involved are glycerol, water, acetal, hydrogen, and also propanediol, 1,2-propanediol. Remember, you have to include all this in the list of components later on. And the property method is an RTL-RK, because here we have polar compound and we have the hydrogen, the vapor, right? That's why we opt an RTL-RK. And in terms of feed information, we have two feed. Remember, we have two feed. And feed 1 is basically the crude glycerol, consists of 70 weight percent of glycerol and 30 weight percent of water. And the feed 2, the flow rate is 5 kmol per hour, and it is 100% hydrogen. So in terms of the reactor information, since the conversion is given, so we know that we have to use R-stoid. The preferred reactor model is R-stoid, and vapor phase is in the reactor. So vapor liquid, because boiling point of glycerol is more than 200 degrees C and 1 bar. So you have to choose the valid phases as vapor liquid. And the reactor operating condition is just the same with the feed. Okay. So these are some take-home messages for our Chapter 3, Part A, focusing on the R-stoid, one of the balance-based model. So message here is You have to know there are different types of reactor model or reactor category under Expen Plus. Like we have balance-based reactor, equilibrium-based reactor, and kinetic-based reactor. And in part A, we focus on R-STOID, right? Balance-based model, which can be used especially when conversion or extent of reaction is given to you. And R-STOID, of course, here can calculate for you the heat of reaction, and also you can perform the selectivity calculation based on the simulation results if you use R-STOID. Okay? And the work here, as mentioned earlier, you have to complete exercise 3.2 based on the analysis that we have done. So with this, I hope you have achieved the outcome for especially R-STOID. You know how to use R-STOID and what is the purpose and when to use R-STOID. Okay. Thank you very much.